All right, so what we're looking at here this time is we are going to start to look at, again, functions and properties of functions, but we're going to kind of focus in on like 5 or 6 specific types of functions, graphs, because what we really want to, these are the ones that you're going to encounter as you move through both this course and for some of you in calculus, or they're the most common ones. All right, so I'm just going to kind of graph a few of them, and there is many ways to graph some of them, especially like this one here, y equals x, where this is a linear function. But I'm going to basically use a table of values for each of them, real small table of values. So usually when I use a table of values, I pick 0. X equals 0 is always the first value I use. Then I pick a couple positive x values and then a couple negative x values to substitute into the function to graph it. So again, this is just a little introduction to some of the graphs that hopefully you've encountered over your life, math career. And so this first one here is a linear function, y equals x. And so if I use x equals 0, well, my y value is going to be 0. If I put a x equals 4 in, I get a y value of 4. If I put an x value of 8 in, I get a y value of 8. Again, I'm going to try a couple negatives. So x equals negative 4, I substitute in, I get y equals 4. And same thing with x equals negative 8, I get a negative 8. So there's our linear equation. Nice straight line there. Again, I'm using a mouse here. This is supposed to be a straight line. All right, now let's get into something a little bit different, which is our quadratic equation. Now, again, there's many ways to graph a quadratic. I usually teach what I call the step method in grade 10. But again, I'm going to use some table of values. And again, I'm going to use 0. So if I put a 0 in for x, 0 squared is 0. If I put a 2 in, though, x equals 2, 2 squared is 4. All right, I can do a negative 1 where I do negative 2 right in here. And negative 2 squared, negative 2 times negative 2 also gives me a 4. And again, this is a quadratic equation because I have a squared here. And so I get a parabola. And there's what our parent graph looks like, which means the original without any transformations, which we are going to talk about on Wednesday, transformations. All right, so there's our linear, again, supposed to be a straight line, and our parabola, quadratic. There's a couple others we're going to look at. The next one we have here, we have y equals 1 over x. Now, this one's a little bit different, and then I try to put in a 0 for x, which would be my first one, but it's undefined because you cannot divide by 0. Okay, so I don't even have that point at x equals 0. It's something we're going to talk about here in a little bit. But then I put in a 1 for x. Well, 1 divided by 1 is 1. So there's a point there. If I put in a, say, 4, x equals 4. Well, 1 divided by 4 is a quarter, and so my x value is going to be right in here somewhere. Now, I'm going to try to put in another one. Say like x equals a half. If you take 1 divided by a half, you get actually 2. And so our graph, a sketch of it, it's going to be roughly looking like this. All right. Now, on the negative side, kind of similar. If I put in x equals negative 1, I get y equals negative 1. If I put in x equals negative 4, I get negative 1/4. So it's going to be right in here. It's going to be close to the line, but not touching it. Okay, that's key. We're going to talk about that. And then same thing if I say put in x equals negative a half. Well, then I'm going to get y is equal to negative 2. And in fact, a sketch of this graph. And there we go. I'm going to put some arrows in there because it keeps going. All right. Now, our next one here, the old absolute value. We have that. Or again, if I put in any x value, no matter what it is, it's going to come out to be positive. So while 0 is neutral, so it's going to stay neutral. That would be the only one. So if x equals 0, well, I have a 0. If I put in x equals 4, y is going to be 4. If I put in x equals 8, well, y is going to be 8. Now, if I put in x equals -4, the absolute value of -4 is 4. So again, what we went through the last class. And if x equals -8, the absolute value of -8 turns it to positive. It's an 8. So there's our absolute value graph. All right. Now, this is our rational equation here. Let's see what else we got here. Okay. Y equals the square root of x. All right. Well, the square root of 0 is 0. Put in x equals 1. The square root of 1 is 1. So there's my y value. And I'm going to pick 4 because I like to pick a nice number here. If I put in x equals 4, the square root of 4 is 2. Now, if I go to put in x equals, say, -4, we can't take the square root of a negative number. So this is a rare equation where it starts at x equals 0 and then it just stays positive in the x values. We never have negative x values. All right, because we can't take the square. So that's our square root function. All right, and let's see here. I think I get 2 more here. Y equals 2 to the power of x, exponential equation, which we'll get into sometime this year. All right, and so if I take 2 to the power of 0, well, 2 to the power of 0 is actually 1, because anything to the power of 0 is 1. All right, let's put x equals 1 in there. Well, 2 to the power of 1 is 2. And then let's try 2. 2 to the power of 2. Well, actually, I'm going to throw a 4 in there. So I guess that might be too much. So let's go with a 3. X equals 3. Well, 2 to the power of 3 would be 2 times 2 times 2, which is 8. All right, now some negative ones. 2 to the power of -1. If you type that into your calculator, 2 to the power of -1, you actually get a half. All right, and if I put in 2 to the power of -2 and you type that into your calculator, you get actually a quarter actually. And what this ends up is this is a exponential equation. It looks like this. All right, so we're just doing some table of values here, just exposing you to some of the graphs that maybe you have seen or haven't seen. I know in my grade 11 class we did exponentials, but we didn't. I don't think we did square root function too often or at all. It's not in the curriculum. Here's another one. The sine x. Y equals sine x. This is one we won't see too much, I don't think. So I'm going to skip this one. We're not going to see this one this semester. All right, now, so there's a couple parent functions. Now, what we're going to look at today, whoops, got to bounce around here a bit. Whoops, just opened up the same graph. Great. Good for me. Okay, yeah. We don't want that one. Let's get this one going here. All right, here we go. So what we're going to look at again is more properties of functions. All right, we have functions. We're going to look at what's called continuity, the end behaviors, and intervals of increase and decrease. All right, and combined, we're going to touch back with domain and range also. Now, continuous function is any function that does not contain any holes or break over its whole domain. All right, so for example, our quadratic there, the parabola y or f of x function notation equals x squared. Now, discontinuity is when we had a rational equation there, as there's a break in the graph of the function. For instance, f of x equals 1 over x, which I'm going to come back to. We did graph that one, but I'm going to come back to that one. Now, we're going to use 2 types of notation. We have what's called interval notation, which I did not use before. I used it once, I think, a little bit, which interval notation, for instance, is described to use, say, for instance, if I have round brackets, and there's a difference here between round brackets and square brackets. Negative infinity to 0 is described using interval notation and is equivalent to just saying x is less than 0, which is called set notation. Now, I don't care which notation you use. I just want to expose you to both types of notation. All right, so again, the use of round brackets in this interval notation indicates that the endpoint is not included in the interval. All right. Now, so that would be an example of, let's see, open, whoops. That's when we had, say, open circle. All right, so that would be a case of when we had open circle. When we did our number line. All right, now, the use of a square bracket in interval notation indicates that the endpoint is included. So again, that would be kind of when we had on our number line, a closed circle. All right, so that's the difference there. And again, when we're looking at set notation, right here, -3 is less than or equal to x, which is less than or equal to 5. I could write that as in terms of interval notation is -3 to 5, but again with the square brackets. So you pick and choose which one you like. Now, here's where things get confusing for students is when we talk about end behaviors. All right, and that's when we're looking at the far ends of the domain. Again, we're talking about the x values and state where the range values are approaching. As x approaches negative infinity, so if we move so far left in our graph, what happens to the y value? Or we can just look right. So we're looking to the left and we're looking to the right. What's going on with our graph in terms of our y values? And again, I'm going to explain kind of how that works. Now, an invisible line, or rarely a curve, and for us, to be honest with you, it's always going to be an invisible line until those of you who join my calculus class, we'll get into the whole curve. That's a special occasion. That the graph never approaches, that it approaches, but it doesn't touch, okay? So no matter how far we go to the right or to the left, or in terms of infinity or negative infinity, the line will not actually touch the graph, but will always get closer and closer. So again, I had this graph that this parent graph, our rational equation, where we have y equals 1 over x. All right, and again, remember when I did our values where I tried to put in x equals 0 in there, right? But it didn't work because you cannot divide by 0. And so I put a positive value of x equals 1 in there. I also did put in a 2 where I got a half. And then I went in between here and I did x equals a half where I actually got the y value of 2. And so it looks like this rational equation. There we go. All right, now, here's the other thing that when we went to the other side, x equals -1, I got y equals -1. And in a similar fashion, I graphed it, and we had this sketch of a graph. Now, in this graph, what I wanted to show you was that this line, because we can't have an x value of 0, this actually has two asymptotes, lines that we can't cross. It won't cross. The first one is there is no x value of 0. And so what we say is it has this is an up and down line. It has a vertical asymptote. Now I'm just going to say VA for short form, VA at x equals 0. But secretly, this one also has another asymptote, another line that it won't cross. And that is this purple line. And that is what's called because it's a horizontal line, it's called a horizontal asymptote. Because the value of y can never be 0. There's no way to make it 0. There's no x value that can make this thing 0. And so I short form it again, HA at y equals 0. A height of 0 can never happen. and left and right can never happen at x equals 0. All right, so we have a VA, what's called vertical asymptote at x equals 0, and an HA at y equals 0. These are things that actually we are definitely going to get into a little more closely later on in the course. But for now, we'll just touch on it a little bit. All right, so now let's go. We're going to go over all these different properties and characteristics of our different functions here. So I threw in a bunch of different functions. All right, so the first one here, and if you have, can I go back up quickly? Oh man, that was 7 minutes ago. I'm sorry, Erica. If you have a question, let me know. All right. Because again, I got my chat on one computer, and when I'm presenting, I can't see the chat. So sorry about that. Hopefully I slowed down a bit. All right, so I'll go a little bit slower too. All right, so here's a function. Again, I got a little squared sign here. So this is a quadratic. Now, I can plug in a table of values, but again, if you learn the step method of A, H, and K, all right, where the H is telling you how far right this graph is shifted, which is 2 to the right, because the vertex is always at 0, 0, the base graph. But this one shifted right 2, and then up 4. So that's where the vertex is going to be, right there. Or again, you can put an X value of 0 in and 1 and 2 and kind of sketch it out. There's a bunch of different ways. I'm going to do the step method here. My A value is -1, and so my steps are going to be -1, -3, and -5. And so again, if you were in my grade 11 class, that's what I taught to sketch this thing. But let's see here. So from the vertex, what these steps mean is I'm going to go left over 1, down 1. Then my next step is -3, so I'm going to go over 1, down 3. Now I go back to the vertex, and I do the same thing. Over 1, down 1. Over 1, down 3. I could go over 1, down 5, because that's my next step here. 1, 2, 3, 4. It doesn't fit. All right, so this is a quadratic equation. And there we go. All right, now I'm going to sketch all of these at the same time. Go through each of their. Well, actually, I won't do that. Let's do them one at a time here. All right, now the domain. All right, so I want to figure these things out. Domain and range. Again, the domain is all the possible x values. All right, and again, that's left and right. Now, see these arrows? Even though this parabola heads downwards, it keeps going left and it keeps going right. And so my domain here is I got all the possible x values, all the real numbers. All right. Now, in terms of my range up and down, this parabola has a height of 4 here. It goes down. That's the max, and then the min, it just keeps going right down. And so for my range, let me get a little different color here. My range, oh, I forgot to use my little domain notation here, little d. There we go. Just make it a little prettier. All right. Now the range, again, all the possible y values. Let's see here. So it starts at 4. That's as high as it goes, and then it goes down to -infinity. So what I'm going to say here is that the range is y is less than and equal to. I'm going to use what you guys, some of you used in the chat. Y is less than and equal to 4. All right, now here's where things get a little bit different. Intervals of increase. All right, now when you're looking at this graph, what you're looking at for intervals of increase and decrease is you're looking at when does this graph go up. And so you have to read the graph left to right. All right, now when I look at this graph, now we talked about the fact that it was going down all the time and stuff when I'm looking at domain and range. And that's what messes people up with this, is that the domain and range, you have a different perspective in terms of intervals and increase and decrease. Because intervals of increase and decrease, as I mentioned, I'm going to read it from left to right. So as I go to the left, I pick it up at this arrow, this purple arrow here that I'm hovering over. And when I'm reading this left to right, the graph goes up all the way to the x value of 2. Now, it has a height of 4, but it's going all the way up till I have an x value of 2. Then it starts turning back down. Again, I'm reading the graph left to right. And so I'm going to use interval notation here. Now, I'm going to have a round bracket. Whoops, a round bracket at the start. Because here's the thing. I don't have a symbol for infinity. Shoot. All right, so I'm going to have to draw a circle in here. You can never get to infinity. You can never have that number. So it's always round bracket. So I'm going to start from negative infinity. So that means as far left as I start following this parabola, and as it keeps going up and up and up to right here at x equals 2. So I'm going to put a negative infinity and then a comma 2. Now, at the very top of this parabola, the very, very top, that function is neither going up or down. So because it doesn't include 2, I do a round bracket there. Now, intervals have decreased. After this vertex of this parabola, the function just goes down. All right, so intervals have decreased from 2, x equals 2, onwards. We're always talking about the x's here. So as x goes from 2 onwards, it just keeps going down all the way to infinity. And because you can never hit infinity, it's a theory round bracket. All right, so again, a little bit of different thing going on there. Any asymptotes here? No, we don't have any breaks in the graph. It keeps going and going and going. And so this graph doesn't have any asymptotes, which means it is continuous. We never have to take our hand off the paper. That's the difference between discontinuous and continuous is, can you draw this graph without taking the pencil off the paper? And in this case, you can. All right, zeros, x-intercepts. Yeah, we got a spot where it hits the x-axis. Again, these are more properties of our functions. It hits here at 0, 0, and hits here at, I believe, 4. X equals 4, 1, 2, 3, yep, 4. So our x-intercepts are x equals 0 and x equals 4. Better drag that over. Y-intercepts, again, that's when we're talking about where does it hit the y-axis. Well, up here it does. It hits at 0. So throw that in there. Y equals 0. Or I guess I can just, x equals 0. Same thing. Or I guess y equals 0. That's one spot. There we go. That's our y value of when it hits the y-axis. See if we can move that. All right, now here's another tricky spot. End behaviors. So again, this is a perspective thing. And this is where people get confused with intervals and increase and decrease. Intervals of increase and decrease, again, we're reading the graph from left to right. But end behaviors, it's like we stand at the origin. We look far to the left. We look far to the right. We want to know what's going on, all right? And so what I'm looking at is as x approaches negative infinity. So if I look far left, what does your y do? And as I looked to the far right, which is x equals infinity, approaches infinity, what does y do? All right, so if I look at my graph and say, let's color code it here. I'm looking from this green line, and I look to the left. Where does my graph go? It just keeps going down, down, and down, which means it approaches negative infinity. It keeps going down, down, and down. Now, back up to end behaviors. If I look far to the right, I keep looking far to the right to infinity. This graph also just keeps going down this parabola from this side of it. So again, it approaches negative infinity. So again, different perspective. End behaviors, it's like you're looking in the middle of the graph, looking far to the left, far to the right. But yet when you're doing the intervals of increase and decrease, you're looking from left to right. That's what students always get confused about that. All right, so that's a quadratic. Okay, we're going to try another one here. We have 1 over x plus 2. Okay, so I'm going to plot that graph. Let's see, x equals 0. I plug that in, and I get a half. So it'd be right in here somewhere. All right, let's try x equals 1. I would get 1/3. Well, that's in here somewhere. Let's try x equals -1. If I have a -1 in the bottom here, I'd actually get 1. Let's try -2. Ooh, -2 here can't happen, right? X equals -2, because then my denominator is 0. So that can't happen. I can never have x equals -2. Kind of means, well, it does mean I can't cross this line here. Again, this is our reciprocal function. Rational, you can see it. So it's going to look like this. It's going to go up like that. Now we have dots on the other side of this red line. All right, so I'm going to put in, say, like x equals -3. X equals -3 means I'd have a -1 in the bottom. And so x equals -3, y would equal -1. All right, and so I'm going to plug that in. Let's see here. There we go. So the graph's going to kind of look like that there. All right, now, domain. All right, domain. Left and right. Right? That's all about our domain. What can we have or can't have left and right? Well, we got all these values to the left of this red line. We have all the x values right of the red line, but we can't have an x value at the red line. And so here's a little bit of different domain, is that our domain, whoops, change color here, just separate things. Let's go with green. Our domain is squiggly brackets, x, I don't have these symbols on my phone here. All right, so let's go with this. X cannot equal 2. Or sorry, -2. Cannot equal -2. So it can equal everything but -2. All right. That's not a 3, by the way. That's a squiggly bracket there. Now the range. Let's see here. Can we ever get a 0? Because we got all the values below the line and all the values above the line of y equals 0. But we can never, there's no x value there we can sub in and get a 0. And so my range, and this just takes experience of working with these functions to understand this kind of stuff, that y can never equal 0. And so what I should be doing here is going up and fixing this a little bit, right? Kind of got a little, well, I got a mouse too, so it's a little crazy. And just got to draw it above the line. There we go. Fix that up. All right. Now, intervals of increase and decrease. So again, this is where we're talking about looking in the left to right, what's happening with our graph, right? And behaviors is different where you're looking in the middle and then looking to the left, looking to the right. But intervals of increase and decrease, we start our view just like we're reading, and we look at the intervals of increase and decrease, seeing how the graph goes. So as I travel down my purple line here using my pen, I'm going down a little bit. So I'm decreasing actually right now. And then I keep going down. So my interval of decrease from -infinity from the far left, and then I get to the red line all the way to -2. I'm decreasing. But again, nothing's happened at x equals -2. So I'll put a round bracket there. All right, now I get up here. See where my pen is? I'm way at the top because that's the next part. But look I keep going down the whole time. And then I get to this spot where my pen is. And I'm still going down little by little, but I'm still decreasing. So I have another interval of decrease. And again, I can't include x equals -2 because I got that red line there. But as I keep going all the way to infinity. And so in fact, for intervals of increase, we don't have any. if we read this graph right to left, it never approaches, it never decreases or never increases, right? As we follow this graph, it never increases, always decreases, except for at x equals -2 because nothing's happening there. All right, zeros, x-intercepts. Let's see here. Yeah, there's one there. I believe that was at y equals discontinuity. This, I got to make this graph bigger in the future. Discontinuity or asymptotes. Well, yeah, it is. We have an asymptote. We have actually two of them because our x value can never be -2. So I have a, trying to write this in here. It's a little hard when I have my thing. I have an HA, horizontal asymptote, or sorry, vertical asymptote, because that red line there is up and down at x equals -2. I also have, sorry if this is messy. It's a little hard on my smartboard here. I also, this value can never be 0. This function, we can never put an x value in here to make it 0. And so I have a horizontal asymptote, an HA at y equals 0. I could draw that in actually as a nice little red line. There we go. So there's two asymptotes, which means we have discontinuity. Because again, discontinuity refers, and I could write that in, or I should write that in, but I can't because I don't have enough space. All right, but anytime you have an asymptote means you are discontinuous. And again, that refers to the fact that I cannot draw this graph without lifting my pen up. All right. Zeros, x-intercepts. We have an x-intercept. Let's see here. When does it touch the x-axis? It can't. That's why it has a horizontal asymptote. So I'm going to write none. It doesn't have a x-intercept. Can never touch the x-axis. But it does touch the y-axis right up here where you see my little arrow. I believe that number was a half. Let's see. Or you can just sub in x equals 0. And yeah, I do get a half. So we got y equals 1/2. There we go. All right, again, if you have any questions, feel free. All right, now end behaviors. So again, this is where the whole perspective thing happens. So what happens when we look far to the left? These are arrows, by the way. And what happens when we look far to the right? So you're looking in the middle of the graph. What's going on? So I'm going to start right here, up my pen here. I guess I'll mark it with blue. That's my perspective. I look at this graph going far to the left. What happens here? This graph approaches, keeps hugging this line, right? So in fact, it approaches a height of 0. Again, I look from that blue dot. I'm looking far to the right now. Where does that purple line go? It hugs the line. It approaches 0. But again, because it's an asymptote, it approaches it, never touches. All right, next up here, let's go with another one. Ooh, a little different one here. Again, I'm going to have to use some table of values here. Let's see, try a 0. When x equals 0, then I have 2 to the power of 0, which I just know is 1. All right, x equals 1. So then I would have 2 to the power of -1. I put that in my calculator here. 2 to the power of -1 is actually a half. 2 to the power of -2. Put an x equals 2 in here, and I get a quarter. All right, let's go the other way here. If I put x equals -1 in there, it means I'm going to have two negative signs come together to give me a positive, which means I'm going to have 2 to the power of 1. It's up here. All right, x equals -2. Again, a negative sign from the equation and a negative sign from a -2 will give me a positive 2. So I'd end up 2 to the power of 2 here, 4. So again, I'm just plugging in different values, x values. And here we go. So there's what my graph is going to look like. All right, now the domain. Again, when we're looking at the domain, all the possible x values, we'll look at the arrows here. It goes far to the right. There's no breaks. It goes up as it goes to the left, but essentially it can go anywhere. We can have all possible x values. So the domain, again, is all your real numbers. Or again, if you want to use interval notation, goes from negative infinity to infinity. Again, there's options there, all right? The range. Let's see here, y values, the up and down. This thing goes way up, so there's no top level. This thing keeps going up and up and up. But look at this thing here as it goes down to the right. I don't think there's any way this gets to 0. There is no number I can put in for x that gets it to 0. And so for the range, we're going to have y is greater than 0, not equal to, because we can't get to 0. All right. Now, intervals of increase and decrease. Again, this is when we're reading the graph left to right as opposed to the old end behaviors. All right, now, as I read this graph left to right, so I'm going to start up at the top here, it just keeps going down, 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 down a lot at the beginning. This is an exponential decay. Oh, no, actually not a decay. Yeah, it is exponential decay. It starts going down slowly, and it keeps going down, but not as much. But either way, from start to finish, this thing decreases. Or sorry, decreases. So I put that in the wrong spot. There we go. So from start to finish, this thing decreases, which means it never increases. Because again, we're reading the graph left to right. Horizontal asymptotes and vertical asymptotes. So there is no vertical. There's nowhere where this thing just stops and cuts off. But yet, see this red line here is it never goes below 0, never even gets to 0. And so then I would say, okay, we have a horizontal asymptote at y equals 0 because it approaches that line but never gets there. X-intercepts. When does it reach the x-axis? Well, if we have, again, a horizontal asymptote at that spot, it never does, so none. Y-intercepts. Yeah, there's one. We saw it hit the y-axis right here at, I believe it was 1. But again, if you ever want to find the y-intercept, you just put in x equals 0. And that would mean 2 to the power of 0, which, of course, again, is 1. And so, yeah, there is a y-intercept at y equals 1. All right, now, again, the old end behaviors. Okay, so the end behaviors. So, again, I'm going to start in the middle of the graph. This blue dot right here. All right, so I'm going to look infinitely to the left. That's what y approaches negative infinity means. Figure out where this graph goes. I'm going to approach, then I'm going to look at this graph infinitely to the right. So that means x heads towards infinity. Where does y go? All right, so again, as y approaches negative infinity, that means I'm looking to the left here. And this purple line just goes up and up and up and up and up, keeps going up. So as we look at our graph from the left to way to the left, it's always going up. Back to my blue point here. As I look at the graph to the right, and it keeps going and going and going and going. It keeps going, and it's going to go towards our horizontal asymptote, which is 0. There we go. So we had a mix there. One, it shot off into infinity, and the other, it looking to the right, it hugged that asymptote and went to 0. All right. So there's a bunch of different characteristics of a few of our graphs there. All right, now let's see here. Function notation. This is something I definitely did in grade 11 for those of you who are in my class. Just a little recap of function notation. If I have a function f of x and it equals 3x squared minus 4x, find f of 2. What that means is this f of 2 is find y when x is equal to 2. That's all that means. And so for a, we have our function here, which is 3x squared minus 4x. And so to find that out, f of 2 is equal to, let's see here, I got 3 times x, and we know x, it's 2, to the power of 2 squared minus 4. And again, I got to substitute the x in, which is now 2. All right, and so if I find f of 2, let's see, I got to follow Bedmas here, all right? So I'm going to go a little quick here. 2 squared is, I might as well write it in there. You got to do exponents first. So 3 times 4, all right, minus 4 times 2. All right, just following Bedmas, and what do we get here? 3 times 4 is 12, minus 8, we get a 4. All right, so I can do the same thing here over in B. F of negative 1 just means find y when x equals 2, or sorry, when x equals negative 1 this time. And so that just means we're subbing in a negative 1 for x, trying to. All right, and so again, I'm using the same function over there of 3x squared minus 4x. So I have 3 times negative 1 squared minus 4 times negative 1. But again, I got to follow Bedmas. All right, so I got 3. I got to do the exponents first here. Negative 1 squared means negative 1 times negative 1, which is a 1. Minus 4 times negative 1. All right, then I'm going to multiplying here. And all I'm going to have here, well, 3 times 1 is 3. But then I got negative 4 times negative 1. Negative times a negative gives me positive. We get 7. All right, so that's just a little recap of function notation. Now, again, what does it mean? Well, get to see here. 2 points located on this curve, because it is a curve, it is a quadratic equation, a little different one than we're used to. But right here, it's telling you, hey, when x is 2, y is 4. So one of the points is just simply 2, 4. The x value is 2, the y value is 4. The other point, well, I already got one here. When x is negative 1, the y value is 7. So those are just 2 points on that graph. There we go. Again, any questions so far? It's a long lesson here, man. I don't usually go this long, I'll be honest. All right, let's see here. Last example. We're going to just describe a function in graph one. Random graph, all right? So each set of characteristics describes a function. Draw a possible graph. So there's many answers here. And state whether the graph is continuous. All right, so this graph, random graph here, has a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 3. Wow, what does that mean? First off, vertical asymptote at x equals 1. Vertical, up and down. So our graph here can't, there we go, can't cross that purple line. Let's see here, horizontal asymptote at y equals 3. So that is a left and right line. So we'll throw that in there. There's our asymptote. Now we have to draw a function, which means this thing has to pass the vertical line test. Okay, so I'm just going to sketch something in there. I don't know. These are the asymptotes. So let's see. I could draw a line right here. Your internet connections get help here. Oh, let's see. That didn't, I don't know what happened there. Okay. So again, I'm going to draw a line. A little, maybe throw some squiggles in there, and then it's got to go up to those asymptotes. There we go. There's possibility. And then again, I want to draw a function here. So I don't know, I could draw it up from here, but I can't cross the asymptotes. So I'll draw something like that. But again, that passes the vertical line test. Maybe I should have made that last part a little bit better. There we go. Something like that. There we go. All right. Is this thing continuous? Could I draw this graph without lifting my pen? No, I couldn't. So that means it is discontinuous. All right. So are you guys still seeing me and hearing me? Okay, thanks. All right. All right, last one. Here's the range. This thing goes from -3, less than or equal to, or y is greater than or equal to -3, but y is less than or equal to 2. The interval of decrease is from -infinity to infinity. So this thing decreases the entire way. Okay, but yet it only goes from -3 to 2. So I'm just going to try to draw a little bit of limits in here, but so it's going from -3, the range here. So we're talking about our up and down. Now these are just like an invisible line that it just helped me out to draw this thing. All right, and then the upper end is 2. And it's including it. Okay, that's key too. It's including it because we got the equal sign there. So, all right, so I'm going to draw something. So it's always decreasing. All right, let's see here. So it doesn't say anything about the domain, right? So again, I can just draw some random function here, long as it's decreasing the entire way. So it's going to be equal to, so I'm going to put a little closed dot here. And then just draw a function that decreases the whole way. And then let's see, it gets down to there. There we go. So there's a possibility. Again, many answers because it's saying a possible graph. But the range of it is from -3 to 2. It decreases the entire way. Again, decreasing is reading it left to right. And is this function that I drew continuous? Could I draw it without lifting my pen? Well, I did. So it is continuous. And there we go. So there is a lot of different things we went through. I really find, again, students get confused on the whole end behaviors, intervals of increase and decrease. Again, the asymptotes are just lines, invisible lines that they can't cross, so they values that we can't get with a function. And then other ones are like our y-intercepts and our x-intercepts. Those are things that you've dealt with before. And of course, domain and range is something we dealt with earlier today.